Welcome to grayyeonmath. We are asked to solve this problem. We have this semicircle that overlaps this yellow circle, and uh, from this point A to point M to this M is the point of tangency between the semicircle's horizontal line to with the circle. So the distance from A to M is 8 units, while from this point of tangency to the lower right of this semicircle is 2 units, and a line is drawn from the points of intersection between the semicircle and the circle at P to Q, which is this red segment, and we are required to find the length of this red segment. Okay, so first thing that we can do is we can actually draw the radius of this semicircle. So from P to the center B, and from O to the center B. So from O to B is the radius also. So we can label this as capital R, and this is also bigger R, capital R for the radius. And we notice that this OB is a perpendicular bisector of this PQ. So perpendicular and bisector. So this means that these are equal. Okay, so next is we draw the radius of this yellow circle. So from O to P. So and we label this as small letter R. And likewise for this O to Q, it is also the radius of the yellow circle. And also from O to the point of tangency at M. So this is also radius, small letter R. Okay, so our main focus is about this triangle POB, this triangle POB. But first, we need to get this to get the lengths of this capital R and small letter R. Okay. Okay, so but if we want to get this capital R, it is actually the diameter of this semicircle. So represented by AC over 2, diameter divided by 2. So radius is simply equal to AC, which is AM plus MC, AM plus MC over 2, and R is equal to AM, which is 8, plus MC, which is 2 over 2. So this gives us 10. So radius is equal to 5 units for the semicircle. Okay, so next is we get this length BM. So BM. Okay. So this is actually simply BM is a part of the radius of this semicircle. So the radius R is equal to 5. Okay. So, but the radius is actually can be represented by the length from points B to Q. So B to Q. So BQ is equal to BM, this BM plus this MQ. So plus MQ. Okay. So this is BM. So BQ is actually equal to R is equal to 5. So 5, we can replace this by 5. And BM is the unknown. Plus MQ, which is 2. So BM is equal to, if you put this 2 to the left hand side, you have 5 minus 2. So BM is equal to 3 units. Okay. Okay, so next is I have isolated this triangle BMO. So it is actually a right triangle with the hypotenuse of 5 units, and this one leg is 3 units for BM. So we are have only one unknown, which is the small letter r. So r is simply equal to the square root of the hypotenuse squared. So r square minus this bm squared. So we have r is equal to the square root of 5 square minus 3 square. So this gives us 25 minus 9 gives us 16, square root of 16. So this gives us r is equal to 4 units. Okay, so next is we have isolated this triangle POB. So we already have the three sides. So our aim is to find the length of this. This is actually the half of what we are looking for. So this red segment. So we must first find the area, okay, of this blue triangle, and then if we have the area, then we can represent this. I mean, if you have this area, we can represent this in another way to find the height. This height, this is actually the red segment is actually the perpendicular height, and if we find the area, we divide this by 1/2 and this length, the base, which is OB. So, but we just need to find the area for now. So, we can actually use the Heron's formula. So, but before we use that, so we need to find the semi-perimeter, which is half of the perimeter of this triangle. So, S is equal to 5 plus 5 plus 4 all over 2. So S is equal to 14 over 2. So S is equal to 7 units. Okay, so by Heron's formula, the area is equal to the square root of the semi-perimeter times the semi-perimeter minus one side. So A, S minus B, and S minus C. And in our case, so area, in our case, the semi-perimeter is 7, and 7 again, minus one side, which is 5. So, since there are two 5, so we need to repeat, and S minus 4. Oh, I mean, S should be 7 already because we already know this. Okay, so 7. So, area is the square root of 7 times 7 minus 5, this gives us 2, and 2 again, and 3. Okay, so we can actually get this out, this 2, because this is a perfect square. This makes a perfect square, I mean, so 4. So this, we can put this outside, so we have 2 times the square root of 7 times 3, which is 21. So that is the area of the triangle POB. Now that is in square units. Okay, so since we already know the area of this triangle, so that is and we can write it in the formula in a different way. So area of POB is equal to 1/2 times the base, which is base times the height. So the area of POB is 2 square root of 21 is equal to 1/2 times the base. We have the base here to be 5. Okay, so 5 times the height, which is the unknown. This is actually what we are looking for. Okay. I mean half of what we are looking for. So if we simplify, h will be h is equal, we just need to cross multiply, so 2 times 2 square root of 21 and divide it by 5. So we put this 2 here and this 5 on the denominator. So h is equal to 4 over 5 square root of 21. Okay, so what we got as h is actually this length. So this length is h, half of a pq. So this is h also. So h. So simply pq is equal to 2h because OB is the perpendicular bisector. Okay, so PQ is equal to 2 times H, which we have the value of 4 over 5 square root of 21 units. And we just simply multiply this 2 and 4, so we have PQ to be 8 over 5 square root of 21 units. And that is our answer. So thank you for watching until the end of the video. Please like the video if you like our solution and don't forget to subscribe to the channel and hit the bell icon so you will be updated for more math videos like this. Thank you. Bye.